Hello learners, welcome to our first lesson in calculus with analytic geometry. Before going to calculus proper, we first review some concepts that you have learned from your college algebra. And to be particular, let's talk about the Cartesian plane. Recall that the Cartesian product is written by this symbol A cross B. This is the set of ordered pairs AB such that A belongs to big A and B belongs to big B. Suppose A is the set containing 0, 1 and B is the set containing wxyz. Now, A cross B is defined as such. Also, recall that the two-dimensional Cartesian coordinate system is defined as R2. Again, R2 is the set of ordered pairs xy such that x and y are real numbers. Geometrically, this is done by intersecting two lines of perpendicularity. The horizontal axis, x-axis, and vertical axis, known as the y-axis, intersect at a point known as the origin. This intersection divides the plane into four quadrants. Normally, the units of measurement along the two axes are the same. We establish the positive direction on the x-axis to the right of the origin and the positive direction on the y-axis above the origin. If P is the point associated with the ordered pair, xy, and the abscissa, or the x-coordinate, is positive, P is to the right of the y-axis. If it is negative, P is to the left of the y-axis. Similarly, if the ordinate, or the y-coordinate, is positive, P is above the x-axis. If it is negative, P is below the x-axis. The x and y-axes are called coordinate axes. So, these are different location of points in the Cartesian plane. Now, let's talk about the quadrants. The first quadrant in the upper right portion of the plane is the one in which the abscissa and ordinate values are both positive. Quadrants 2, 3 and 4 follows quadrant 1 in a counterclockwise direction. Alright. Let's talk about distance between 2 points. Let P and Q be any 2 points in the plane. The undirected distance or simply the distance between these points is denoted by d. The distance between the abscissas can be expressed as x2 minus x1. While the distance between the ordinates can be expressed as y2 minus y1. Since we have formed a right triangle, this allows us to obtain the value d using the Pythagorean theorem. Using the same Cartesian setup, we can also locate a point midway between P and Q, and that is done by adding the same component of points divided by 2. That defines now the midpoint formula. For example, find the midpoint of the line segment from A with coordinates 2, 3 and B with coordinates 5, negative 4. We first define M to be the midpoint of line segment AB. Then we have. This figure is a quick sketch of the segment with endpoints AB. And it's clear that the midpoint is the one with coordinates 7 halves, negative 1 half. The following are examples of equations in X and in Y, and all of these equations can be graphed in the 2D plane. By definition, ordered pairs of values for X and Y that satisfy an equation in X and Y are called solutions to the equation. The set of all solutions to the equation is called its solution set. Take note of the following remarks. 1. Given an equation in 2 variables, specifying a value of x will result to value or values of y. 2. Ordered pairs of real numbers satisfying an equation in x and y can be interpreted as coordinates of points in the 2D coordinate system. 3. The graph of an equation in x and y is the set of all points on the Cartesian plane whose coordinates satisfy the equation. For example, consider the equation y equals x squared minus 1. Using the table of values we can set values for x and their corresponding values in y. We just locate these points in the Cartesian plane, and since we have an idea that this is a quadratic equation, then we just connect the points with a smooth curve. Another example. The equation y equals square root of x. Again we use the table of values to see different points contained in this equation. And since square root functions are considerably half of the quadratic functions in terms of graph, then we also connect the points with a smooth curve. Take note, not of a stiff and straight line. You can also do the same technique of graphing in cubic functions. However, in some cases, you cannot get close enough to the actual graph of cubic functions. And this will be further discussed in sign analysis using derivative tests. Another important concept in graphing is the utilization of the intercepts. Again, we define x-intercept to be a value on the x-axis intersected by its graph, and y-intercept to be a value on the y-axis intersected by its graph. And to solve for x-intercept, we just let y equals 0. Similarly, to solve for y-intercept, we let x equals 0. Let us go back to the equation y equals square root of x. If y equals 0, then x equals 0. If x equals 0, then y equals 0. Clearly, the graph of y passes through the origin. In the case of y equals x squared minus 1, notice that the graph intersects the x-axis twice. That is because when y equals 0, we could have two values for x, 1 and -1. And when x equals 0, y is equal to -1. In our next video, we'll talk about equations of a line, slopes, parallel and perpendicular lines. Thank you for watching. See you in the next video.